I want you to picture this. You're driving down a highway. Rolling hills stretch out on both sides, and then you see them, those massive white wind turbines spinning slowly against the sky. One blade, two blades, three blades, always three. You've probably seen hundreds of them, and they all look exactly the same. Three blades every single time. Why not four? Why not two? More blades should mean more power, right? But here's the surprising truth. Engineers tested turbines with two blades, four blades, even dozens of blades, and three won. Not because it's cheapest, not because it captures the most wind, because of physics, balance, and a problem nobody saw coming. Today, we're uncovering why turbines have exactly three blades, how more blades actually kill efficiency, and why two blades would save millions but will never happen. To understand wind turbines, we first have to look at a problem engineers wrestled with for centuries. How do you extract maximum energy from moving air? The earliest windmills had dozens of blades. Those old Dutch windmills, 8 fabric sails. American farm windmills, 20 thin metal blades packed in a circle. They were horribly inefficient. Why? Because they tried to catch wind like a boat sail. The logic seemed obvious. More blades equaled more wind captured. But engineers eventually realized something critical. Windmills don't work by catching wind. They work by creating lift, the same force that makes airplane wings fly. And when you pack too many blades together, they fight each other. The air that's turbulent, each blade blocks the next. Think of it like a crowded subway door at rush hour. Everyone pushes, nobody moves. So the question became, what's the perfect number? The core explanation. Part 1, the physics. Here's what happens. Each turbine blade is shaped like an airplane wing. Wind flows over it, creating low pressure on one side and high pressure on the other. That pressure difference pulls the blade forward, but when a blade spins, it leaves behind disturbed air, a wake. If the next blade comes too soon, it hits that messy air instead of clean wind. 4 blades, too close together. The turbulence kills efficiency. 5 blades, even worse. 3 blades hit the sweet spot. Each blade gets clean air. The rotation stays smooth. Maximum power extraction. Part 2, the balance. So if 3 is efficient, why not 2? Two-bladed turbines actually work. They're lighter, cheaper to build. Denmark tried them in the 1980s, but they had a fatal flaw: wobble. When a two-bladed turbine spins, the weight keeps shifting. One blade up, one blade down. The mass swings back and forth. Now scale that to a 300-foot turbine in high winds. The vibrations destroy the gearbox, they crack the tower, and they create a low-frequency hum that travels for miles. People nearby reported headaches and sleep problems. 3 blades solve this completely. 1 blade up, 2 blades down. The center of gravity stays constant. The rotation is smooth and silent. It's the same reason helicopter rotors have multiple blades. Balance isn't optional. So if 2 are unstable and 4 are inefficient, why does 3 always win? Part 3, the money angle. Here's the brutal truth. Each turbine blade costs about $200,000 to manufacture. 3 blades means $600,000 per turbine. That's expensive. But here's what that third blade buys you: longer lifespan, less maintenance, and public acceptance. That last one, huge. Wind farms need permits. They need neighbors who won't sue. Two-bladed turbines feel a lot different. They create a flickering shadow when the sun shines through them. Communities hate it. 3 blades spin slowly enough that birds can avoid them. They look symmetrical, safe, elegant. Communities rejected two-bladed designs even when proven safe. Psychology matters. The industry did the math. The energy output, reduced maintenance, and public approval pay for that third blade 10 times over. 3 blades aren't just physics. They're physics plus economics plus human nature. The conclusion. So next time you see a wind turbine spinning on the horizon, don't see it as just a big pinwheel. See it as a perfect engineering compromise. Every blade is a $200,000 decision. Every rotation proves that the best design isn't the one that maximizes one thing, it's the one that balances everything. 3 blades, not by accident, by calculation. If this surprised you, hit like and subscribe for more hidden stories behind everyday things, because the world is full of common things with surprising histories.